joining us. My name is Jane Thompson. I, as of next Tuesday, will be the new VAVF president. So we're just delighted to have you here. We have our next session is U plus UEB Math equals Success by Kyle DeJute. Our opening code for this session is Nemeth, or Nemeth, depending on how you pronounce it, capital Nemeth, Nemeth. I would like to just another announcement to please fill out your evaluations as you finish a session. It is very important to us and our funding and to plan future conferences. We really need your input and feedback. So let us know what we're doing right, what we can do better, and what we can do different. We need to hear that from you. Let me take this moment to introduce to you our presenter for this last session today, Kyle DeJute. Kyle is an employee of the American Printing House for the Blind. She is the Braille transcriber training coordinator for the printing house. Kyle's job is certainly not easy. Many of you know the printing house is quite large, over 330 plus employees, and we do have certified transcribers in every department at the printing house because we do require everything to be as accessible as possible. So it's Kyle's responsibility to make sure that everybody is skilled up in all of the codes, all of the coursework. She does presentations all over the country. She is on the board of NBA. She presents at CTEBVI, and of course, she's right here with us at the VAVF conference today. So at this time, I would like to introduce to you Kyle DeJute.
Hello. Thanks, Jane. I'm going to turn on all of my things and share my screen and have a camera. We're just going to do it all. Oh, I don't need a virtual background. I'll get very distracted. Bear with me for one moment, please. Maybe. Come on. Oh, of course.
We can see your PowerPoint, Kyle.
Good. I just want to make sure to turn off whatever filters are going on, because my kid was helping me with filters the other day and she made sure that we had all of the like makeup things turned on that are in beta. And y'all deserve better than to see me with like weird purple digital lipstick going on and off on my mouth. That's a whole different kind of presentation, which is not why we're here today. Why we're here is to talk about UEB Math. Jane, thank you very much for the lovely introduction. I'm Kyle. I'm a white woman with short brown hair, and if you're watching the video feed, you can see I've got a little springtime flower behind one of my ears and my APH shirt on today. So let's dive right into it. What words are we using? Let's talk terminology for a moment. Very recently, the Braille Authority of North America published a document that they approved on September 21st of 2020. And the title of that document sort of says it all: terminology, UEB Math/Science and UEB with Nemeth. So these are the terms that BANA is recommending everybody use for clarity. There's been, we've all probably experienced it, some confusion about exactly what code is this book in, exactly what code or code combination did you want me to use to transcribe this thing. So this document is intended to allay some of that confusion by suggesting terms that could be used across the board for when we use only the UEB rules for math and science, or when we would use Nemeth within switch indicators. What we're talking about today is UEB Math Science. So I'm going to try to use the appropriate terminology all the time. We are talking about UEB math. We're not talking about UEB math and formats, really, and that's largely because there is a recording of another time that we all got together on the FIMC website. There's a recording of the webinar when we talked about formatting. So if you go there, this is that page that's on. I'll go ahead and paste that link into the chat so you can easily get there, because I know when we're done here, you're going to want to watch a recording of another webinar about formatting and exercises and displayed material and where we look for guidance on how to format a lot of the stuff that can come up in a UEB math science transcription. So that's why we're not talking about formatting today. Now let's get down to our foundations, the GTM. So that's the guidelines for technical material. It is part of UEB, right? The rules of UEB is one file, and the guidelines for technical material is a separate file, but when their powers combine, they are the complete rules of UEB. So the guidelines for technical material is separate from rules of UEB in electronic files and in sort of the physical printouts of those files, largely just to keep things from being really unwieldy and huge. But the guidelines for technical material is in fact a part of the full rules of UEB. It's part of the rules of UEB that's more focused than what we call the rules of UEB. The GTM is more focused on math and science, the symbols and challenges that come up with those transcriptions. The GTM is also an evolving document. There are updates and sort of errata posted. Those you can always find on iceb.org/ueb.html. And if you want to get real fancy and extend that web address with a pound at the end, and I just pasted that in the chat, that takes you right to the part of the UEB page from ICEB that deals with guidelines for technical material. And from there, you can download the 2014 PDF or BRF of the guidelines for technical material, as well as revisions to that 2014 document, which includes a whole new Section 3 on signs of operation and comparison. And we're going to come back to that, and especially the PDF, because you can do some cool things with the way that document is laid out. This is the only time I'm going to talk about cheat sheets. Cheat sheets are for a quick refresher of material that you already have a deeper knowledge of. Cheat sheets aren't really for learning because, they're cheating. They're little summaries of information, and our cheat sheets are certainly never our primary sources. Our foundational or primary sources are the rules of UEB, which includes the guidelines for technical material. I don't mean to say that cheat sheets are bad. I just want to make it very clear that cheat sheets are most helpful as a reference, and they're not something that it's always useful to dig deep into. They're for glancing, right? So one such cheat sheet is the UEB crib sheet, which some of us in-house at APH have put together. The UEB signs and symbols from Volunteer Braille Services in Minnesota is available online. Here's a link in the chat to the PDF for that cheat sheet. It's relatively long for a cheat sheet. So it's multiple pages. It's 5 pages in total, the VBS UEB signs and symbols quick list. And it's categorized into kinds of information. So initial letter contractions, lower word signs, lower group signs. And then as we continue on in the sort of latter pages of this cheat sheet, there's a place where you can add your own. Ooh, and I have happy thoughts about that. There's also in the second to last page some cheat listings for some of the enlarged grouping indicators, square roots and radicals, our UEB math science material. And this link that I pasted to this PDF is actually in the UEB study group Google Drive, which is full of information and has a little collection of cheat sheets. So I think this is the easiest place to get this particular cheat sheet, but like so many, it's stored in a couple of places and accessible from a couple of places. So in the UEB study group Google Drive, which there's a link now in the chat too, under, I think it's, what is the actual folder is called Reference Sheets and Manuals. So it's in that folder that this really sort of exhaustive cheat sheet lives. Now let's go to the last page of this symbols and signs quick list, because the last page is set up with 1, 2, 3, 4, 5, 6 columns, and it's a place for you to add your own listings. And I think that's super cool, because that is something I would highlight as really important to think about with cheat sheets. Sorry. A personal cheat sheet, whether you've made it by yourself with that last page where there's empty braille cells to fill in and you can build your own braille symbol listing, or whether you've physically cut up a cheat sheet and pasted it into your own like 3x5 card, any cheat sheet that you've personalized, even with highlighting, is going to be more useful because it brings to the fore the things that you use most often or that you forget most often. So yeah, cheat sheets are that. They're just for cheating, just for quick reference. So if I start to talk about cheat sheets later, I hope to have the chat light up. It's going, Kyle, you said you wouldn't. You should go back to primary resources, not cheat sheets. Our agenda for today, now that we've gotten terminology and words about cheat sheets out of the way, our agenda is to talk about symbols of UEB Math Science and say a few words about grade 1. I will probably say the phrase grade 1ification, which is my silly term for using a grade 1 symbol, word, or passage indicator to apply grade 1 mode. We're going to touch on dividing expressions, just a sort of checklist for how to think through that, and 2 extra special UEB math science concepts. Those are arrows and bars and dots, etc., over and under. So without further ado, symbols. Again, we're going to go to our primary or foundational sources for symbols of UEB math science. And yes, on the slide on the screen, there's a picture of liquid makeup foundation, because that's a terrible pun and I feel like it belongs there. So our primary sources for the symbols of UEB math science are the rules of UEB, and that includes the guidelines for technical material. And both of those include all of the revisions or updates that are, again, published on that iceb.org/UEB. That's it. Those are our primary resources. For quick study or summary, and especially for refresher of some symbols, I have, under the username Braille Trainer, put together a series of flashcards in Quizlet. And you can use Quizlet online or you can use it in your mobile device. So if you search for Braille Trainer, no space, camel case, if you will, right? Because that little T of Braille Trainer in the unspaced Braille Trainer is capitalized. I've heard that usefully called camel case, like the dromedary camels. Under that username on Quizlet, and again, you can use this online or in a mobile device, there's a couple folders of flashcards relevant to our interests today is the UEB Math Science folder. And in there, there's a set of flashcards that goes along with the recording about UEB math and formats that I mentioned earlier, which is available from FIMC's website. And there's a brief set of flashcards that are UEB math symbols. Now, if you have a particular list of symbols or particular symbol, just the one, that you feel like would be a really important addition to a flashcard set like this, please, please let me know. I would love to have a second brief flashcard set here or a extended flashcard set, or maybe organized by subject matter. That's something I would really love to hear that's something I would love to hear from you guys in the chat, or you can email me. My contact information should be at the end of this guy. And also I'm going to drop it in the chat. All right, so you can go through some Quizlet flashcards, which I hope are useful for drilling the Braille symbols for UEB Math Science, but also I hope are useful for those times when you've been away from math for a little while, whether it's because you didn't have anybody who needed them or any assignments that needed it, or because you were at the beach and now you're back at work and you need some sort of brain warmer upper. Flashcards are good for that. And I like the way that Quizlet offers multiple ways to look at flashcards. You can go through them, or you can do like a learn mode where it'll have you matching flashcards with the two sides of the flashcard, the term and its definition. Sometimes it even does multiple choice questions in a learn mode. So again, if you have suggestions about symbols or a category, please email me or drop that in the chat. So what if you are looking at your print and you see a symbol, you don't know what it is, and you don't recognize it in print, or you don't know what the Braille equivalent is. Here's a couple of quick thoughts on ways you can look that up. We can use our terms in primary sources. So, right, our primary sources are the, hello, I didn't want that, drag that. I wanted to drag my PDFs of rules of UEB and guidelines for technical material. And in either of those, we can control F to search. And depending upon what you're looking for, you could look for maybe a root, hello, which would take you to the table of contents listing as your first result. And maybe you're looking for that cube root that's got that cute little, hello, that's got that cute little 3 sitting on the root symbol, on the little seat of the root symbol. And that's can be a quick way to find a symbol in our primary sources, is to search for the terms that are used to talk about those symbols in the print. We can also use ASCII in those primary sources to search for Braille symbols. So if you maybe are looking at Braille and you see a symbol that you don't recognize, and especially if it's not listed on the special symbols page, we can search. Let's get a little smaller so we can see what's going on. We could search for we just enter the ASCII equivalents of the characters, the Braille characters that we're looking for. So maybe I'm looking for this series of symbols. If I were to search from here, the way that these electronic documents of the rules of UEB and guidelines for technical material are set up, everything that appears as Braille or simulated Braille, visible Braille, in these documents is ASCII characters with a simulated Braille font applied. So if you can put in the print ASCII characters that correspond to those Braille cell configurations, you can look directly for the Braille symbols. One convenient way to get ASCII is to 6-key enter into a Braille transcription program and then copy the Braille cells that result from your 6-key entry. This is obviously not something you can do in PerkyDuck, but you can do it via the 6-key entry tool in Braille Blaster or via the Braille document in Duxbury. And I think you can 6-key enter anywhere in Braille 2000 and copy that Braille that you get, or just go to your print view if you've got things exact translated. So that's one convenient way, if you don't have all of the ASCII symbols memorized, that you can enter the ASCII into your primary sources and look directly for Braille symbols. When you look up a symbol, please do remember to apply grade 1 if you're going to enter the Braille into a transcription, right? Once we find the symbol, that doesn't mean that we're done, because a symbol like the root symbol can have a grade 2 meaning. For the root symbol, that would be SH. So we have to apply grade 1 when we actually use that Braille symbol in a transcription. Speaking of roots, let's take a look at an example. Please examine the following Braille transcriptions and think about which one is correct. So for the square root of 100 equals a gray shaded box, we have what sometimes looks like the SH contraction, then numeric indicator, 100, and then the Braille cell 346, 2-cell equals, and then the parallelogram shape. Our second option for this transcription has a grade 1 symbol indicator, then the what looks like the SH contraction, the number 100, and dots 346, the 2-cell equals, and the gray shaded parallelogram. Third and finally, our option here has a grade 1 symbol indicator, what looks like the SH contraction, a numeric indicator, 100, the 2-cell equals, and then the shaded parallelogram. I'm resisting the urge very hard here to sing the Jeopardy theme while you think. I'm seeing some twos. I'm seeing some second options. Before we get rid of any options, let me give you this sort of hint. If you have a root, it has to be closed, kind of like a little greenhouse. You got to close that door on the root so that it's all closed up and nice and warm and cozy for your number that's inside, or your material that's inside the root. The root has to be closed. That means it can't be option 3 because option 3 didn't have our close root. And then concern, there's another concern here with option 1. You guys are so right that it's 2. Option 1 is missing grade 1ification. So what option 1 says is 100 visible space equals shaded parallelogram. So yes, the correct option is the second option, where we have grade 1 symbol indicator, root sign, number 100, and then grade 1 mode is in effect from this numeric indicator at the beginning of the 100 when we get to our close radical. And we have to have our close radical because radicals always get closed, or else, to continue the greenhouse analogy, our little shoots would wither and die if we didn't close up that root. So we have to have, this closing symbol. Then the 2-cell equals and the shaded shape parallelogram. Parallelogram is that 3 cells, dots 4, numeric indicator, and dots 1, 4, 5. Let's do it again, this time a little bit faster. Here are your 3 options. The first has no grade 1ification for square root of x equals 8. The second has a grade 1 symbol indicator, and the third option has a grade 1 word indicator before the square root x and close root indicator. I'm seeing some 3 and 2. Well, let's talk about what it isn't first. It's not that first one. That little suckaroony is missing a lot of grade 1. That says shksing equals 8. So it's not that. And it's not number 2 because that says square root of ching or square root of x ing. It is in fact the third option. So our transcription of square root of x equals 8 is grade 1 word indicator, square root symbol, x, close that square root, equals 8. And our grade 1 word indicator here is enough because the equals sign does not need any grade 1ification. It has no grade 2 meaning. And the piece of the expression on the right side of the equals is a number, so it doesn't need any grade 1ification either. Okay, let's do another one. This one is a different beast. Triangle, space, all caps ABC includes cap AB with a ray notation with a right pointing arrow over it. So here are your 3 options. The first one has no grade 1. The second option has grade 1 symbol indicators before the shape indicator for the triangle and before the opening grouping sign, opening braille grouping sign for AB. And the last one has grade 1 for this shape and a grade 1 word indicator before the opening braille grouping sign, A, B, close braille grouping, and the specific little guy that means right pointing arrow over. So I'm seeing a lot of 3s, which is one of my favorite numbers. And I think you might be right. So let's first do away with our no grade 1. I mean, that says ed 3, cap ABC, includes gahabar, right pointing arrow. So it's not that one. Our second option is a shape of a triangle. Perfect. Triangle, space, cap ABC, also perfect. Includes, okay, opening braille grouping, AB, GAR, right? We have nothing to grade 1ify this closing braille grouping indicator. So it means AR can't be that one. You are so right. It is option 3, where we have our shape and the number 3, which is a triangle, cap ABC, includes, and then in braille grouping indicators, the AB with the right pointing arrow. So grade 1. I think we know, and it's always good to have a reminder, that grade 1 is required to distinguish those lowercase a through j from numerals, because they have exactly the same braille cell construction, a through j and 1 through 0. So for example, if we had 77 lowercase g, we need a grade 1 symbol indicator before that g, so it doesn't say 777. For 2 lowercase a, same deal. And for 18 BC, we need a grade 1 symbol indicator before the lowercase b that comes after the 8, so it isn't read as a 2. And then once that's established, we're no longer in numeric mode, and our C is okay just following after the BC. We've broken the spell of numeric mode with the grade 1 symbol indicator there before the B in 18 BC. Conversely, we don't need grade 1 to distinguish a capital letter from a numeral, because the capital indicator breaks the spell of numeric mode. So if we had 77 capital G, well, we can essentially transcribe what I just said in Braille. Number 77 capital G, because a number can't be capitalized. As soon as we see the capital indicator, we know that we're no longer in numeric mode. We're not in Kansas anymore. If a document is uncontracted, we're going to need very little grade 1, because we really, in an uncontracted document, need very little grade 1 mode. We only really need it for the A through J distinguished from numerals, because most of the time that we need grade 1 mode, we need it to distinguish a symbol from its contracted meaning. But if we're not using any contractions, then we don't have to make distinction between the symbol and a contraction. So if the document is contracted, we're going to need more grade 1 mode than we would need if the document were uncontracted. And we're not going to go way down into this rabbit hole, but it is, of course, true that grade 1 can be applied in various ways. We can use the grade 1 symbol indicator, grade 1 word indicator, and the elegant but unwieldy sometimes grade 1 passage. The goal, regardless of how we apply grade 1 mode, our goal at base is to make the meaning of the symbols clear. So even if we don't choose exactly the right grade 1 exactly the right grade 1 indicator, if we achieve our goal of telling the Braille reader what the meaning of the symbols is, then we've succeeded, right? I don't want any of us to spend too much of our precious time and energy going, oh, well, word indicator or passage indicator, word indicator or passage indicator. You know, sometimes it's not that big a deal as long as your text comes across clearly, and it does get easier over time. So we don't want to tie ourselves up in knots too much. Let's look at some examples. What we have is 55, lowercase e. The question is, which is the correct transcription? Numeric indicator and then 3 cells of dots 1, 5, or numeric indicator 2 cells of dots 1, 5, and then a grade 1 symbol indicator before the third and final dots 1, 5. Oh, yes. Yes, those 2s are flying into the chat. Yes, the second option, the last option. Get out of here, 555. We need 55E. Sorry, 55 lowercase e. How about for AC? And to be 100% transparent, in print, the AC is italicized. You have 3 options. I think I saw some more input that it's 2. And the question is, the first option is numeric indicator, and then the dots 1, 4, 5, or numeric 1 and 1, 4. The second option has a grade 1 symbol indicator before the dot 1. And the last option has a grade 1 word indicator before the dot 1. Yeah, I think I've seen probably nothing but 2s from the chat. Yeah, it can't be that first one because, sorry, let me bring it back for a minute. That means 413. And it doesn't need to be our last one because just a grade 1 symbol indicator is enough to break the spell of numeric mode. So our transcription should be a numeric indicator 4, grade 1 symbol indicator AC. Like I said, you don't want us to get tied up in knots, so our considerations for applying grade 1 mode partially come from the BANA, Provisional Guidance on Transcribing Mathematics in UEB, which, come here, document, I want to look at you. So the link in the PowerPoint takes us to this page, and if we go to the PDF, down to the bottom of page 4, the principle that we're about to see the results of is unless a math expression can be correctly represented with only a grade 1 symbol indicator in the first 3 cells, or of course before a single letter standing alone anywhere in the expression, begin the expression with a grade 1 word indicator so that we're not interrupting. The result of this not interrupting principle is that grade 1 symbol indicators within the math expressions are largely avoided. We don't want to be whispering in the Braille user's ear in the midst of a long fraction, hey, this is grade 1 mode. Like, just get it out of the way to start out with so they can just read and have as little interruption as possible. Other consideration is to allow words to be in their usual form, right? We're striving for quick recognition, reading of words. And when a word is uncontracted, but you're used to seeing it contracted, it just takes that extra beat to say, oh, okay, that means pounds. And like I said before, content is our main concern. A graceful application of grade 1 comes after the content is totally accurate. So if you've got time to really consider which is the most graceful grade 1 indicator, a word or a passage or whatever, that's great. But if you only have time for one thing, it should always be double checking your content, and proofreading. Let's talk a little about another way to look up symbols. Sometimes we encounter something in print, and this is especially frustrating when the same print symbol comes up again and again, and maybe we're trying to use Braille transcription software to transcribe into Braille that symbol, but we don't feel like we have a good way to enter that symbol. I'm talking about things other than the plus that's right on a standard QWERTY keyboard, or the equals that's right there on the same button as the plus, the exclamation point, which is also factorial. Those are super easy to enter, but when we're dealing with maybe a capital sigma or pi all over the place, those can be a pain in the butt to enter. So one way to find the electronic version, the actual electronic character of the math symbol that you're dealing with, is to search online the surrounding vocabulary that talks about that symbol. It may even be identified and called something. And if you do a Google search, often it can take you to the Wikipedia article about a symbol, and they're right in the first sentence definition of the symbol is the actual symbol you can copy and paste out of the Wikipedia page, and it is 9 times out of 10 the Unicode character that you can paste right into your word processing document or your Braille transcription software and get the Braille symbols that correspond to it. We should always double check that we're getting the right thing when we just copy from the internet into a document and transcribe it, but it does work quite frequently. And before I forget, let me just state or restate that in addition to that cool thing where you can search ASCII to find Braille symbols in our foundational primary sources, we can also, and you know what, for this one, I'm going to open up our new section 3 of the guidelines for technical material. Come here, new section 3. Come on. I know you're new and you're shy. So all of the entries in the print column of the PDF of section 3 for guidelines for technical material are copy pastable, and they are the appropriate Unicode character, which if you paste it into a Braille transcription program is very, very, very likely to give you the appropriate Braille cells. I'm a little bit of a fangirl of these accessible and really quite well laid out print versions, print PDFs of the primary sources, because this copy paste thing it's really nice. Okay, so if we're looking for a symbol and the print material we have does not give an actual name for that symbol, we could describe it, just give a physical description of what appears in print on the internet, where someone else has probably also asked the question, hey, I've got this thing that looks like, I don't even know what, that looks like a hard line E with some slanty lines. Oh, you might come up with that is the capital sigma. And all of this is true largely because of a principle of the guide of UEB, which includes the guidelines for technical material. And that is one of the goals of UEB is to be back translatable, is to have the Braille be easy for computers to make print out of, and for the print and for most print to be easy to make Braille out of. Now, we know as transcribers sort of in the trenches that this does not work 100% of the time. And I think more than at many points in the past, we have a situation where if we have the electronic character that actually means pi, for example, and we put that into a Braille software program, we are likely to get the actual Braille cells, and vice versa. If we get print from a Braille document and we have the dots that mean pi with grade 1 applied appropriately, then we get the appropriate print that we expect. So UEB is trying to be really back and forth translatable. Entering symbols of UEB Math Science. So we've talked a couple of times about how you can find information about symbols in our primary sources and online. This is kind of a summary. How can we enter symbols? Well, we can type them. If you got a plus and a QWERTY keyboard, you can probably push a button and get the plus sign. We can copy paste from our primary sources, especially if you're looking at the electronic PDF. We can copy paste from online. I will admit to not always having my electronic primary sources right at my fingertips, but I do almost always have an internet connection, and I could copy paste from something like Wikipedia, which is using an electronic character that I could put into a Braille translation software. And the UCAF, the United Kingdom Association for Accessible Formats, has written up a process for using math autocorrect in Microsoft Word to easily type in math symbols, or at least to type in a sort of shortcut that allows us to get math symbols quickly. So what it ends up looking like And I would strongly encourage you to go to, let me paste this link in the chat right now while we're talking about it. Hold on, come here. So first of all, I would strongly encourage you to go and read this document. The link will take you to this page, which is where a number of Braille related documents from UCAF are listed. And if you scroll down under publications, if you choose the PDF option as opposed to the docx or BRF options, under the PDF option under publications, we would choose Math Autocorrect. And that opens the actual PDF, which describes a couple of ways for generating mathematical symbols using Math Autocorrect or Unicode. So if you use Math Autocorrect in Word, it kind of looks like that, where you type a slash, a backslash, right? Yeah, a backslash, and then the word or symbol that corresponds to the word or abbreviation sort of that corresponds to the character that you're looking for. So those are some ways to enter symbols of UEB math science. And the picture on the screen is a table chock full of big and little bowls of food with lots of people reaching in to clink their glasses for a toast. The idea being there are lots of different ways to sort of serve up these symbols. You can grab them from different bowls and get a delicious plate full of beautifully back and forth translatable math, or at least math symbols. Come here, go to the next slide. Okay, deep breath, move around a little bit because we're going to talk about a new concept. We're going to divide expressions because that's everybody's favorite thing to do. First off, you got to know how much space you have. So expressions don't get divided within a vacuum. There's a picture on the screen of sort of Tupperware containers in various sizes. The idea being we can have more or less of the Braille line available to us for a math expression depending upon what format we're in. If we're being displayed to a narrative paragraph, we're probably in cells 3, 5, and we have most of the Braille line available to us. If we're dividing a math expression that's displayed to a second level in an exercise, then we are over in 7, 9, and we have much less of the Braille line available to us. So first question for dividing expressions is how much space do you have? And for more on margins and formats, you can look to that UEB Math plus Formats recording that's available from FIMC's website. I think we start talking about that at timestamp 2254. And then the way that I think through dividing expressions after I've established how much of the Braille line I have available is first, divide at those baseline signs of comparison. Divide before each baseline sign of comparison. And then second, divide between mathematical units, right? UEB, the whole rules of UEB does not provide us with a hard and fast checklist for where you have to divide. So we get we're allowed to use more of a math-based philosophical approach for dividing expressions. First, I would suggest dividing before baseline signs of comparison. And second, between math units. Now, those are often separated by signs of operation, but not always. Sometimes our math units, we have nothing but a series of grouped expressions, things that are each in parentheses. A rough definition of a mathematical unit is a group that works together, like a fraction, like a whole fraction, or a mixed number, right? The whole number and the fraction, the entire fraction together work to give us one value. So let's look at one example and the way that it could be divided. So first, I'm going to say that I have 30 cells because I want to make sure the Braille cells are big enough on this slide for you. I'm going to say that I have 30 cells for this expression, and I'm going to get in there and do all of my symbols, including grade 1 first, so I know exactly how much Braille cells I have. I can't start dividing until I've got all of my Braille cell content in place. So let's look at that first, and then we'll talk about division. I've got a grade 1 passage, and I did that so that my general fraction indicators, I wouldn't have to use grade 1 symbol indicators within the expression in order to grade 1ify those general fraction open and close indicators. I also knew that a grade 1 word was going to terminate at the end of any of these lines. And so I would have had to have a new grade 1 word indicator at the beginning of each line. Thus, I chose to use the grade 1 passage. Great, we've established the first 3 cells of this expression. Then cap FV equals cap PMT, open parentheses, open general fraction. So now we're transcribing this print fraction. Open parentheses 1 plus, right, our signs of operation start with .5 and then have a little symbol that tells us what it is. R, close parentheses, superscript T, general fraction line. So now we're in the denominator, which is R, and that's the end of our general fraction. Minus the fraction 1 over R, end of the fraction, close parentheses, and grade 1 terminator. So the way that I divided this within my 30 cells that I had to work with was to divide first before the baseline comparison sign. So I divided first before broke the Braille line first before the equals. And then my mathematical units are FV, PMT, and this thing that's all enclosed in parentheses. So I kept PMT together and divided before my second math unit after, whoa, hey, come back, after the PMT. Sorry, this is my second math unit after the equals sign. And so I divided before that. The second place that I divided is before the sort of baseline symbol of operation, because my whole parentheses wouldn't fit on 130 cell line. And so I kept one whole fraction together and divided before a symbol of operation. Does that make some sense? I could talk all day about one Braille example, but I think we should probably move on. So here we have x subscript t plus 1 equals kx subscript 2, open parentheses 1 minus x sub t, close parentheses. So let's talk real fast about math units. My variable with a subscript, that's a good measure of a unit. So x subscript t plus 1 is a unit, and kx subscript 2, it's another unit. And then the thing that's enclosed in grouping indicators, oh, that's a good indication that that's a unit. So I'm going to roughly look at 3 mathematical units I have here. And I've got 2 options here. Will you please look at these 2 options and tell me which of these transcriptions is more correct? The first one doesn't have any grade 1 applied. The second one has a grade 1 passage. And the first expression is not divided across Braille lines. The second expression, which has the grade 1 mode applied, is divided before the equals sign. Yes. Thank you for blowing up the chat with 2s. You're totally right. This first one commits the classic blunder of not having grade 1. Instead of x subscript, t plus 1, we have x ENGH T plus, no. So our correct transcription is this guy, where we've established grade 1 at the very beginning with a passage. And so that grade 1 effect applies to this subscript and to this opening Braille grouping indicator before the multi-item subscript. And our grade 1 also applies to the subscript after the x of KX subscript T, and we don't have to interrupt the expression with any grade 1ification because our passage is doing the work. Sorry, there was a comment about the previous example and grade 1. We will go back to that guy in a minute. Let's talk about a checklist for dividing expressions. I'm so sorry that I just hit my microphone. That probably popped in your speakers. So first question, is the expression totally complete, right? Do you have all of your braille cells exactly as you're going to keep them, including any grade 1 indicators? Then I would divide before the main expression's comparison sign. Then before, if you have them, operation symbols in the main expression. And before those operation symbols is a kind of another way of saying divide between mathematical units. Perhaps the most common mathematical units are a fraction. Any material in a pair of grouping symbols, whether they're braille grouping symbols or print grouping symbols. Any letter and its super or subscript, because a super or subscript really drastically changes the meaning of a letter to which it's appended. So
Kyle,
before
it's
we,
Jane. I'm sorry to interrupt. I just wanted to let you know you have less than 10 minutes left, and we want to save a little bit of time for questions because we know we're going to have some. Just a heads up.
Perfect. Let's skip that guy and let's hear a word from BANA's provisional guidance on transcribing mathematics in UEB. I love BANA publication titles. They're so short and pithy. Here's the quote. If you make reasonable divisions following the above guidance, so we're talking about dividing math expressions, if you make divisions that are logical, the .5 continuation indicator mentioned in GTM 1.4 will not often be needed because the meaning or format should make it clear enough that the expression on the new line is a continuation of that on the previous line. So it will typically start with a comparison or operation sign. In other words, the provisional guidance is telling us if for a lot of math expressions, where you divide them makes it very clear that the expression is not over yet, and so you don't have to use a .5 continuation indicator. Let's look at an example of that in action. So our first transcription of 2 open parentheses, x minus 5, close parentheses, superscript 2, and then all in parentheses, 15x cubed plus 67x squared plus 24x minus 16. In the first transcription, there's no .5 used. In the second transcription, there is a .5 used at the end of the first 2 braille lines, right? The ones that are where the expression is still continuing. There's probably an argument to be made both ways. The indentation especially here makes it clear that what's on lines 2 and 3 of this transcription is a continuation of the expression. And the divisions happen between math units. However, this transcription that uses the .5s is not wrong. But the provisional guidance wants to give us the heads up that although you can use the .5 continuation indicator, there are a lot of instances where in math expressions it is not necessary. This is different from a web address where even logical division points in a web address are not consummately logical, whereas in a math expression, the units are nicely defined by parentheses and symbols of operation. And if you're following along with the meaning of the math expression, it's especially clear when something isn't over, unlike a web address. And that's why for math expressions, our .5 is not always necessary. And I think for this example that we looked at earlier, for this expression that we looked at earlier, the lack of .5s here in this math expression that's divided across multiple lines because format makes it clear what's a continuation. I think the lack of .5 makes it so that if we used anything less than a grade 1 passage indicator, the effect of grade 1 would not carry over. So we would have had to sort of interrupt our expression with some grade 1ification. Okay, let me go back to where we were continuing on. Going to do some, I'll do a quick touch on extra special UEB math science concepts. The first of these is that arrows are transcribed from tail to head, no matter what way they're pointing. So a left pointing arrow is an especially good example of this. The way that we transcribe this arrow is from tail to head, even though as we read in an English context, we're reading from right to left, and we encounter the arrowhead first in this left pointing arrow. The way we transcribe this arrow is from right to left, because that's the tail to head order. So the actual transcription of a left pointing arrow with a medium dashed straight line shaft is arrow mode indicator, which has to be grade 1ified and is dots 1, 2, 5, 6. And then the, let's say, 2 cells of dot 2 for the dashed line and the left pointing arrowhead. The other super special UEB math science concept I want to hit on is bars and dots. These are glass slippers. There are common modifiers that appear directly above or directly below text that have specific braille symbols assigned explicitly to them. So that list is in Guidelines for Technical Material, section 12. And each of these glass slipper, bar, dot, right pointing arrow, etc., applies to the preceding item. Louis should take this time for questions if anybody has any burning stuff, or I could fill us in. I haven't seen anything pop up in the chat recently that's a burning question, but I also don't want to keep y'all way over.
Sherry, did you see anything that came up?
No, I've been watching carefully, and just
Okay.
that one that you went back and answered just now was really the only thing that has come up so far.
Great, great. Well, you have about 3 minutes, Kyle.
Oh, good. Let's summarize. So, symbols of UEB math science. Our primary sources is the full, updated rules of UEB, which includes Guidelines for Technical Material. There are loads of ways to look up and to enter symbols for UEB math science, even beyond what we talked about today with searching online, copying, pasting from primary sources or from websites, or even math autocorrect in Word. There's even more. Please remember to use grade 1 as necessary. I always want to say use grade 1 responsibly, which I suppose means the same thing. If we're thinking about dividing expressions, before dividing, got to determine 2 things: how much room we have, or the margins in effect, and we have to determine that our braille is complete and accurate, including any necessary grade 1 indicators. Then we divide before our main comparison sign, before operation signs, and dividing between mathematical units. Our extra special UEB math science concepts include arrows are constructed from the tail to the head always. They are not transcribed necessarily in the order that we see them, but they are always transcribed from their tail to their head. And certain modifiers have glass slippers, specific braille symbols that are assigned just for them. That includes the simple right pointing arrow, a dot over, and a line over, as well as some others. And that's it. Now you will always be successful when you're doing UEB math. Thank you so much.
And thank you, Kyle. You always have so much information and so much knowledge to share. It goes on and on and on. And I know that you would love to continue to answer questions if people have them. They can reach out to you directly or through VAVF. We're happy to pass the questions along. And just again, thank you for sharing your knowledge. Thank you for sharing all of your resources. I think it's been an amazing hour, and it went so fast. I just can't even believe it. So if any questions have popped up, please let me know, Sherry. Otherwise, I am going to go on and do some housekeeping like things. We have a closing code, but we also have 3 door prizes to give away right now if there are 3 people in the room that are on our list. So let's start with, we have the first prize we're going to give away is a geometry tactile graphics kit. And the first name on the list is Toby Eldon, E-L-D-E-N. Toby, are you on? Or Sherry, do you see his
I
name
do
there?
not see his name in the list of participants.
Okay, thank you for checking that so quickly. I appreciate it. The next name is Mia Burton, B-U-R-T-O-N. Mia, if you're with us, if you'll just give us a shout out in the
She
chat
is
box.
here, and she
Awesome.
is, she has said in the chat box that she's here. So.
Wonderful, wonderful.
Yay.
Thank you. The second prize that we're giving away is a tactile book builder kit. And the next name is Jen Lockman. Jen, are you with us?
I don't believe she's here.
Okay.
I don't see her in the list of participants.
Okay. Okay. The next name is Cynthia Ross, R-O-S-S. Cynthia
I
Ross.
don't see Cynthia Ross
Okay.
in the list.
Kevin Murray. Kevin Murray.
Oh man, all these people missing out on this amazing
I
prize.
know,
I don't see
know.
Kevin here either.
Okay. And the last name I have to call is Elizabeth Wilcox. Elizabeth Wilcox, are you in?
There's Elizabeth here, but not an Elizabeth Wilcox.
Oh, I'm so sorry. I'm so sorry. Well, we have more prizes to give away next Tuesday, and we will see you all next Tuesday. I do want to share with you your closing code. Your closing code for this session by Kyle DeJute is technical. I'm going to put that, there we go. Closing code is technical. Everyone, we thank you for joining us today. We have more to come. Next Tuesday, starting at noon, we will be doing a presentation on tactile graphics and creating collage graphics, which is what a lot of teachers do in the classroom, as well as a lot of our transcribers. So we will reconvene next Tuesday, and that will be our last session. We'll also have our VAVF board meeting, our business meeting, and you're welcome to stay for that if you'd like. We appreciate everybody who was with us today. And if you need anything, you have any additional questions, just reach out to us and we'll be happy to get any answers for you. Thank you very much. You guys have a great afternoon. Bye.
Bye.
Thank you.
Thank you, Kyle. Excellent presentation as usual.
That was amazing. So the recording will not stop until I close out the session.
Okay. Well,
I have no way to turn it off without just ending the whole thing. So
yeah, we're just getting some thank yous. Well done.
Yeah, I just want to make sure there aren't any last minute questions or anything like that. So
yeah, I'm not seeing anything at this moment. I thank you so much for hopping in when Liz had to hop out. So
anytime.
And you're
No,
welcome.
I love listening to Kyle. She makes braille transcription seem so easy. But it's also like nice to hear from her and her voice, and she has answers and fun and interactive. So
I agree. I agree. We love her to death. So thank you so much, Kyle. And I'll go ahead and just log out then. And I think everybody, how many we got still in here? Just got a few people left, but we can bump them out when we close out.
Okay.
All right.
Thank you. I will
Thank
see you next week.
See you next week.
Bye. Goodbye, everybody.
Goodbye.